Hello. Can you hear me? Hello, class.
Yes, sir, we can hear you.
Yes, sir, we
Okay.
can hear you.
Okay. Um, can someone brief us what he or she read on the Unit 6? Just a brief summary. Someone should brief us. Oh. I should mention names. Sabismark, please, can you help us? Oh, just the history, the Unit 6 of the chapter 1. Just the history. That one. Mr. Bismarck, or you are not here. So meaning that we didn't read. Mm. Hello, class. Meaning that we didn't read. Can you hear me? The one who said he can't hear anything. Can you hear me?
Yeah, we can hear you.
He just posted that what is going on? Can't hear anything. So I just want to know whether it is from the person or it's from me. And he's not minding me, meaning that the problem is from him. Samuel, please, you can talk if you want to talk. Samuel, you can talk. Yeah, you can talk, Samuel. Okay, so you continue. So this is the database management one, and then last week um, we did the introduction. We saw the drawbacks of the file systems and the advantages over the relational database. And then we also saw the view of data and instances and then schemas. And then the data models, database language, and then lastly, we saw the history. So today our task is to, because in the unit one, we're seeing something like relational. So this session or this unit, we are going to talk about the relational itself, and then the database design. If you are employed, if you've been employed in a company, and then they've given you a database administrator, you should know what a database design is. So that's another task we are coming to look at. And then the the data storage. Where do we store this information, and then what kinds of operations or queries can we perform on these kinds of data storage? And then we have transaction management. We see something like asset properties. So when we get to that side, we'll talk about all these things. And then we'll look at the database architecture. How the database look like, and the rest. And then lastly, the database user and then administrators, those who use the database, the users and then the administrators. Okay. So when we take the relational database, this will be our objectives. Okay. So first of all, let's look at the structure of the relational database. So a relational database consists of collection of tables. So just as we saw last week. So maybe if we have a database school, one of the table can be for the course, and then another table can be for lecturers, another table can be for maybe, let me say, administrators. So that's why we are saying that a relational database consists of collections of tables, because you cannot just create a database with one table. You must have more of them, and each having a unique name. So you can't just give a database, you have a database and then two tables having the same name. It's not allowed. It's not possible in relational database, and even it is not possible anywhere. So A row in a table represents a relationship. So we know that a database is made up of rows and columns. And then they are saying that a row represents a relationship among each set of values. Thus, a table represents a collection of what? Relationship. So your table in, let me say, a table for students will have some kind of relationship with a table for, let me say, courses, because a student take a course. That's what we are trying to what? Understand that a table represents a collection of what? Relationship. It can have only one relationship or more than one relationship. And then you can also make an instance that, example that a lecturer is having relationship with a course and then a student, because a student take this particular lecturer's course, and then this particular lecturer teaches this course. I hope it is clear. Hello.
Yes, sir.
Okay.
Hi.
So in other words, relationship is nothing but a table of values. Okay. So every row in a table represents a collection of related values. I'm sorry. So consider the table. So we are to consider this kind of table. This table here. You see that we have what? Store, product, and then sales facts. We have the store table, product table, and then a table called sales facts. So if you look at this side, you see that with the store key and then product key, it's having a relationship with the sales facts. So here you can see that we have the store key here and then another product key here. So with these two, they all having what? A relationship. That's why we are saying a relational database, because each of the columns here is having a relationship with this particular side. Is that okay? So you will come back to that. So which records product, sales facts, and then store information. So this particular database is doing these three things here. It records products, sales facts, and then store information. And then the store information, yeah, this particular database here. So the database has three columns. So the store table has three columns. It has three columns: name, the store key, the city, and then the region. So if you come to this side, if you can see, this is the database for the store. It has what? Three columns. So this is the first column, this is the second column, this is the third column. And then the column is what? Named. Each of the column is named. So this column is called what? Store key, which is kind of, if you are seeing 1, 2, 3, 4, meaning that this is the ID. That's why we are naming it with key. And then the city, and then the region. Is that okay? Okay. So if you also look at this, it 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 also has what? Three columns. The store key, sorry, the product key, the description, and then the brand. With this one, if you count the columns here is 5. So we have the store key, product key, sales, cost, and then profit. Okay. So we'll come to that. So they are saying that each row or tuple is information about the store. That is the store key, the city in which the store is located, and the region of the city. So likewise, the product table, information about the product consisting of the product key and then the product, the description and then brand. So note that each product is identified by the value of the product key column. So that's what I was referring to. So each what product is what is being identified by this kind of what column. So if I say give me product one, I'm expecting that it's kind of a beautiful girl. That's the description. And then the brand is what? MKF what? Studios. If I say give me product 8, meaning that I am talking about this, the bloodline and then the big studios. That is what this line is saying. Note that each product is identified by the value of the what? The product key column. Whilst each store is identified by the value of the store column. So here too, if I say give me 3, I mean Atalanta and then East. So each product key, or sorry, each key here represents each of the row. Each of the row. So if I say 3, I mean give me this row and then give me this row if I take it in this sense. Is that okay? So they are saying that you can observe that all the values in the product key and the store column are unique. You see that these places are unique. You see, we have 1, 2, 3. If you have a database and then this is 2, this is 2, this is 2, this is 2, then it means that there's something wrong. So if I say give me 2, which of them do I need? There's a conflict. There's a conflict of interest here. So with this one, it won't work because here too, I'm having this side is all 2. So if I say 2, which one am I looking for? So that's why we are saying that each of the keys must be what? Unique. But here we don't care. If the city name is New York, you can as well as have New York here. It doesn't matter. But what matters most is the key. The key should be what? Unique. This kind of keys should be unique. This product key and then the store key, they should be unique. Okay. So if you can see here, you see that the brand for the product, we have MKF Studios, we have another MKF Studios. But if you look at this product key, you see that all of them is what? Unique. But this, we don't care. So make sure whenever you are dealing with this kind of keys, all of them is what? Unique. That's what we are talking about. So keep in mind, keep this in mind. We will come back to this. Yes, of course, we'll come back to this. Mr. Lawrence, do you want to talk? Okay, so the sales table store information about sales consisting of product key and then store key. So this sales facts, or let me say sales table, it consists of this key and then this key. So within our sales table, we are having a key from different what tables. Okay. So and then so it consists of the product key, store key,
Hello, sir.
the cost. Yes, yes, boss.
Please, I can't see your screen. Or it's my network. Okay, that's come. Thank you.
You can't see my screen. Can you see
Come
now?
now, I can see it now. Yes, yes.
Okay. So each row consists of a pair of what? Um, I think I'm lost. So let me start. The
Pair of
sales
product key.
table information. Okay, so the sales table stores information about the sales consisting of product key, store key, sales cost, and then profit column. Each row consists of a each row consists of a pair of store key and then products. Is it? Okay, so that's each
So
row of
it is
sales.
comparing table A to table B.
Come again.
I thought you were trying to locate where the store key is, and I said it's comparing the store table to the product table. The statement.
But I can't see any compare here. Or is it that something that you are saying?
Yes, yes, please. Sir.
Oh, okay. Thank you.
Each row
So
consists
each
of a
row,
pair of key and a product key. So when you got there, you were trying to locate where the store key is and where the product key is, and I said it is found in the store in the product tables.
okay, I get you. So each row consists of a pair of store key and then product key. Thus, each row in the sales facts indicates that the store and then product key are related. So all that we are saying is, all that we are saying is, you see that this and this can be found here. This key and then this key. So this store key and then this product key can be found in the sales facts, meaning that this and then this, they are all what? Related. That's why we are saying it is what? A relational database. If it is not relational database, meaning that this is a separate entity. This is also another separate entity. This is also another what? Separate entity. But once we link this to this, we link this to this, meaning that they are all what? Related. They are all in what? In a family. Okay. So in other words, sales product is linked to the store which sold the item. So if I come to this, if I take one and then I check one, so meaning that one is what? New York, and then the region is what? East. So I come here and then this row is also what? Corresponds to this. So the juror, and then the sales that they made is $2.39, or the cost and then the profit. So that's what we are talking about. So this and this, they are all what? Related. So in a relational model, the term relation is used to refer to tables, while the tuple is used to refer a row. So if we say what is a relation refers to the table, and then a tuple refers to the row. So when we say relation refers to the tables here, and then the tuples refers to the what? The rows. The row. This is one row. This is what? A column. So don't confuse yourself with rows and then column, because with database, rows and columns are what? Very key. So you have to note that. Okay, so they are saying that similarly, the term attribute refers to the column. Hello, I hope you are with me. When we say attributes, attributes are each of the columns in the table. So attributes are the columns within the table. And so this illustrated in 2.2. So we have, okay, so I will explain that 2.2. So refers to the blah, blah, blah. So we have what? Relational instances. On the other hand, refers to a specific instance of a relation. So that is containing a specific set of rules. So if we come here, so it's saying that relation instance, on the other hand, refers to a specific instance of a relation. So that is containing a specific set of rules. So the instance of a student table is shown in 2.2. So this is what? An instance. Because I was also making reference with instance. This is one instance, this is another instance, this is also what? Another instance. So this a whole thing here is what? An instance table of a student. Please, I hope it is clear.
Yes, sir.
Okay, thank you. So it has what? 5 tuples. Let's check if it is true. So I said the tuples are the rows. If you look critically from my mouse, the tuples are the rows. So we have one tuple, another tuple, three, the third, fourth, and then the fifth. So that's why they've named this side tuples. So we said tuples are the rows. Okay. It has 5 tuples corresponding to a 5 student. So the term domain of an attribute refers to a set of permitted values that the attribute can take. So let's try to understand the domain. It's saying that the domain of an attribute refers to a set of permitted values that an attribute can take. So we said the attributes are the columns, not that. Hello.
Yes, please.
We said the attributes are the columns.
That's it.
So if they are saying that the domain of an attribute refers to the set of permitted values that can take. Let's come here. So if we are saying that an attribute is a column, and then we have a name here, from your programming perspective, if we are saying names, meaning that we are talking about strings. Do you get me?
Sure.
Yes. So in your name column, you don't you, I don't expect to see something like 1, 2, 3, 4, 5, 6. No. You can do that, but how you specified in your query will matters. So in the name in this column, all that we are saying that it should take only what string values, and then age. Age, probably is like integers. You can't state double float here because in this world there's nothing like my age is 2.5 or 21.5. Maybe I don't know if we have a person like that. So this place is also expecting what integers, and this address is expecting what strings. Richard.
Yes, sir. So please, talking about the age 2.5, the data type. In case I want to do a relation and find the specific maybe period or the specific age for a person, I think the integer will bring the whole number. But if I want to also know the month, how do I
Nah, that's why here there's no month here. Your age is age. If you are 21, you can't say I am 21.5.
Yes.
Yes. So that's what we are saying, that the age expects something like integers.
So
Unless
if you want
maybe,
to,
unless maybe you want to do it this way, age, then you create a month column. Then you do maybe I am 21 and then 5 months. You can just do that. It depends on how.
for the month, what data type do you use for? What data type do you use
How?
for?
Yes.
You use?
So it all depends on you. If you want to do the month as strings, maybe you can just say I am 21 and then that one quite won't work. So unless you use integers. So I am 21 and then 5 months. Do you get me? 5 months old. Hello, the one who asked that question.
Please, I'm around. My only my misunderstanding is when you use integers, it returns whole number. But
Yes.
here is the case: you want to find period. Let's say someone is 2.5 years, which is 2 years and 5 months, right? So okay, I
And then
understand.
I am saying that there's no way you will do that in this site. If when you apply for, let me say, a job, if you go to them, do you tell them that you are 21 and then 5 months? Hello, Mr. Richard.
Sir, please, I'm around.
I'm saying that when you apply for a job and then they ask you how old are you, do you tell them you are 21 years and then 5 months?
No.
Yes. So definitely you say the whole number. So there's no way in your database I should see something like 21.5 if I am talking about age. That's the structure.
Okay. Okay, so this is limited to this particular table, right?
Sure, but in a later table that you have age, you can't do something like 21.5 unless.
For example, say GES have a portal.
Mhm,
Now in the portal, when you log in, you are able to see the number of years, months, and days that you are to go for retirement.
yes,
Now,
so
what?
so all that I'm saying is, then probably they have another what column like this.
Yes,
Name what month,
yes,
days, and those kind of things. Do you get me?
yes.
Probably they have another column with that information.
Okay,
Do you get me?
yes.
Okay, I saw someone's hand up.
So it was me. I wanted to give a similar experience in relation to
Okay,
states. You know,
okay,
employees use the month in addition to the years to determine when a person is going on retirement. And so
okay.
perhaps another instance could include that particular month.
Mm-hmm. Okay, so the domain is clear now. So the domain refers to what? An attribute, and then we know that the attributes are the columns. Okay, so for example, the domain of age attribute of the student is a set of all possible values, whilst the domain of names is a set of all possible what? Student name. So these are the attribute names. So we have the attribute name called ID. We have the attribute name called name, age, address, and then GPA. And then the attribute values, and then the attribute. So these are the attributes, and then the tuples, and then the relation. So a domain is considered atomic. Mr. Henry,
Hello, sir. Good morning.
good morning.
Sir, so please, if I understand you very well, looking at the table, the one you just scrolled, meaning that the numbers become the attribute values, the
Yeah.
names becomes
Not,
attributes.
not really the numbers. Everything
Okay.
here, Alice, Lynn, Joyce, and those things here are the
Yeah.
attribute values.
Okay.
Do you get it?
So everything in the various let me say cells. Let me use cells here. So everything in the various cells becomes the attribute values,
Exactly.
and then the headings of the various columns becomes the attribute names.
Attribute names, yes.
Okay, and then so what about the attributes itself?
So the attribute refers to each of the columns. Do you get me? That's why they
Okay,
are saying the attribute name ID. So this is one forward attribute.
okay, sir.
Do you get it?
Yes, sir. So the whole column becomes the attribute. The column titles
Exactly.
become the attribute names, and the
Yeah,
values in the
yes,
various cells become the attribute values.
exactly.
Thank you, sir.
You're welcome. Okay, so the domain is considered atomic if a value of a domain are considered to be indivisible units. So, for example, if a student relation had a marital status attribute, then the domain of the marital status are set of possibilities: married, single, divorce. It cannot be divisible into parts. Who can explain this to us? For example, if a student relation had a marital status attribute, then the attribute of the marital status has all possibilities: single, divorce, married. It cannot be what? Divisible into parts. Hey, sorry, it cannot be subdivided into parts. Hmm? Who can explain it for us? Hello, class. Okay, Mr. Henry, you can go ahead.
So I want to give it a try. I don't know actually, but I want to give it a try.
Okay.
So what I see here is that if the relation, as in the whole table over there, has a relation called student, has a marital status attribute, as in if there is a column for marital status, and then the various options over there are the married, single, divorced. It means that there cannot be any other sub, let me say sub values or sub.
So something like married and single.
Yes.
That's what we are trying to explain here. You
Okay.
cannot subdivide these things again, but with some other what attributes you can what subdivide them, because we don't have anything like married and divorced. Either you are divorced.
That's it.
Come again.
What if the person is married but unhappy?
Oh, how can you marry? No, then it's you have to solve your own happiness.
All married be married. All married be married.
Yes,
Married
all
but
married to be
complicated.
married, but complicated. How can you tell me this? Sorry, we don't want anything like that. You are
Okay,
married,
sir.
you are divorced. We don't have anything like married, but married and divorced. No, 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 no. Okay,
Okay, sir.
Mr. Richard.
So please, there can be an instance in search. What I'm thinking is that someone can say married but complicated. If you want to do that, I think you should have a value that falls under the marital status, which you have inscribed married but complicated. If it is part of that column, then it means you can also use it as a value.
If you do that, meaning that you've what subdivided them into parts.
Okay.
So it should be
Except
what like one word.
it's the same marital domain. They said the domain of marital status is. I have created a table. I have a column named status, marital status, and the values I have there is married, single, divorced, married but complicated. You see, these are all options that a user can select from. So when it falls under one column, I don't think it's a subdivision.
Okay, I get you. I get you. I get you.
Yes.
I
So
get you.
it falls and it becomes one option under a column,
Under one column. Yes.
which can be used as a value for any selection that the user wants. Yes. Thank you very much, sir.
I think Obed.
Yeah, I agree to some extent to what my colleague mentioned, but considering what we are studying now, what I realized from the explanation provided so far is that the general response for what is your marital status is the option that has been provided for us.
Okay.
And so by that, we are saying that response cannot be subdivided into other units. And that is how I understand that.
Okay, so let's move on. So we have something called now. So the now value is a special value and signifies that the value is unknown or does not exist. Not is unknown value is not equal to a zero value or a field that contains space. So the null again, the null value is a special value that signifies that the value is unknown or does not exist. Not is not this unknown value is not equal to what? 0. So if you have a column which is unknown, or the value there is unknown or does not exist, it's not equal to something which is 0. That's what we are saying. Or a field that contains space. If it doesn't exist, it doesn't mean that it is equal to 0 or it's equal to something that contains what? Space. So if you come here and then we have a value called unknown in this side, it's not equal to something which is 0, or if there's a space here. That's what we are talking about when it comes to the null. A null value is a special value that signifies that the value is unknown or does not exist. It's different from a value which is 0 or contain what? Space. Please, I hope it is clear.
Yes, sir.
Yes.
We are still at a unit 1. Okay, so let's move on. Database schema. Unit 1, we saw something like schema. Who can define what a schema is for us? It is even here. A database schema is a logical design of the database. In other words, the skeleton structure represents the logical view of the entire database. It defines how the data is organized and how the relation among them are what? Associated. It formulates all the constraints. So the last time I said constraints are just the rules that are to be applied to the data. So the database instance is a snapshot of all the data in the database at a given moment. So when we say a snapshot, at that time that you create, you open the database, what are the things in the database? That's what we are talking about. The instances is the snapshot of the data in the database at a given moment. Okay, so a relational schema consists of a list of attributes and their corresponding domain. So what are the domains? Hello? What are the domains? Oh, just now. We've forgotten what the domain is.
Sir, they are the permitted values.
They are the permitted values. Really?
Yes, that an attribute
Permitted.
can take.
And then what are attributes?
The columns.
Are you sure? Madam, are you sure?
Yes, the attributes are the columns.
Within
Okay,
they are
so
columns in a table.
okay. So the domains are so the domains refers to the domains of an attribute refers to the set of permitted values. Okay. So considering the table, considering products and then the store relation or the store table. Figure 2.1, the schema for the relation can be written as product key, product description, and then brand. So if you look at this table, this particular tables here, they are saying that if you want to write the schema or the schema for that relation can be written as this. So the name of the table, the product key, the description, and then the brand. Whatever that table entails, if you are writing the schema for it, all that you need is to write all of the things in that data table. So, and then the store as well. So before we continue, take a moment and write down the schema for the sales facts and then the student relation in figure 2.9. So that one you can do it yourself. And then another thing is the keys. We are coming to the keys. So consider 2.2. Pause for a moment and then brainstorm ways in which we can uniquely identify tuples in any of the words relation. These things I have already spoken about it. Because I said the tuples are the rows, and then each of them what uniquely identify the row. Okay, so the key is an attribute or a set of attributes that helps to uniquely identify a tuples, which is the row, in a relation or in a table. Keys are also to establish relationship between a different what tables and then column. So if you look at this particular thing, if I say 5 from this side, which is San Francisco, and then west, it's kind of what having what relationship to the product, which is this sense and then sensibility, and then the brand, which is this. So if I say this 1, if I say 2 means that I have a relationship, these two having relationship with this product key, which is the 7. So it establishes relationship between the different tables and columns of a relational database. Individual values in the keys are called key values. A key could be either be a combination of more than one attribute. So one or more than one combination of more than one attribute, which is the column, or just a single word attribute. So the main purpose of key is to give each record a unique identity. So for example, in figure 2.1, the keys for the product relation can be only product key attribute, the combination of the brand and then description, and all of the attributes, product key, brand, and then the description. So we discuss the types of the keys that we have. So we have, these are the types of the keys that we have. We have super key, candidate key, primary key, and then foreign key. So when we say something is super, meaning that something is above all of them. So it's saying that it's a set of one or more attributes that can be taken collectively, uniquely identify a tuple in a relation. This means that all those columns of a table are capable of identify the columns of that table uniquely will be considered as a super key. So a super key is a superset of a candidate key. So we'll come to the candidate key later. Please, I'm coming, Amy. Some do you want to talk? Okay, so the super key. So this is a set of one or more what attributes that when taken collectively. So if we come to this table here, or let me use this. If you take what the ID and then age, or even we add the address, we can say these things are what the super key, because it's saying that with the super key, it's a set of one or more attributes that, when taken collectively, uniquely identify a tuple. Please, I hope you are clear. So a super key is a superset of candidate key. So we'll come to the candidate. So the candidate key is a minimal set of attributes value that can uniquely identify a tuple in a relationship, in a relation. So in other words, candidate key are minimal key. So this refers to the minimal set of attributes. These kind of things are a little bit confusing. Uh, mm. So let's put it that way. So let's say that a candidate key uniquely identifies a tuple in a relationship. So when we come to this side, I think maybe age, name, and then maybe your ID can be what? A candidate key. because you can have a student with 3.1 what GPA, but we want an instance where each word identify the person uniquely. So that's why I'm saying that your name identifies you what uniquely. So the name, ID, maybe age, or age, you cannot even consider age because you can have someone who is also what 21. But let's say the ID and the age can be, let's say, a candidate key, just as we said for the super key. So let's come to the primary key. So this refers to the candidate key that is chosen by the database designer. So that one is being what? Chosen by what? The database designer. That one, I can even say that my primary key should be city, of which it is not something that you have to do. So mostly we choose the primary key with the one with the what? The integer values. So this store key is a primary key, this product key is a primary key, and then this two. So we'll come to that. Let me leave it here. So this is a primary key, this is a primary key. We'll come to the store fact. It's also what? Another key. So we'll come to that. So there can be only one primary key in a table. Also, the primary key cannot have the same values repeating. So I have explained these things for in a row. For example, in none of the values in the product column has what repeated values. The designation, designation of a key represents a constraint in the real world enterprise being what model. Okay, so let's come to the foreign key. So a foreign key is a key used to establish what relationship between two tables. So let me go back to the table again. You see that with store facts, you can see the store key and then the product key. So these keys are what foreign keys, which what establish the relationship. If these things are not here, meaning that there is no what relationship among this. So foreign key is used to what establish what relationship. So foreign key are essential for maintaining a difference between two entities that might be linked with the same information, but do not have a similar information. Okay, so you can consider the store key and the product key in the sales part are foreign keys. So, and then we have the referencing relationship. So referencing, so in this case, the sales fact relation is called referencing relation. So of a foreign key dependency, while the store key is what? Sorry, while the store and then the product relation are called referenced relation of the foreign key. So we have referential integrity constraint. Consider that the value appearing in the specified attributes of any tuple can reference relation among a referencing relation also appeared in a specified attribute of at least one tuple in reference relation. Okay, so we have what is called the composite key or concatenated key. So the composite key or concatenated key refers to a set of two or more attributes that can help identify each tuple in a relation. So refers to a set of two or more attributes that help identify each tuple in a relation. So the attributes in the set may not be unique when considered separate. However, when taken together, they ensure uniqueness. And then we have the unique key. So this refers to an attribute or a set of attributes that uniquely identify each records in a relation. So all of the values will have to be unique in this key. So the unique is just to make sure that all the primary keys do not have the same values. So each unique key differ from a primary key because it can have only one null values, whereas the primary key cannot have any null values. So in your primary keys, you shouldn't have anything like a null value. If you get anything like null value, you are in a big, you are causing a big problem. Okay, so let's look at the schema, a schema diagram. So a schema diagram is just a representation of the database schema. So with the primary key and then the foreign key, dependencies and other relationship are in a pictorial form. So all that we are saying that a schema diagram represents what a visual, let me say, it is what a visual representation of how your database looks like. So it contains the foreign key and then a primary key dependency and other relationship in a pictorial form. So if you look at this, this is a database diagram. Sorry, a schema diagram. So we have supplier table, we have a customer table, we have order table, we have shipment, item, and then product. So if we start from the customer side, the customer orders a product. So that's why we are having a relationship here. So you submit, and then the order table request from the product. And then the product also, this is the item. Then so it follows in this manner. Then if the item that the person orders is within the product, then it will come to they will send it to the person, the customer who orders the thing. So a customer submits order, and then the order table requests, and then upon requested on, then used in, include, and then include on. We will see all these things later on in the chapter. Okay, so this is a brief summary of the unit 1. So there's some things that you have to look at, and then there's an answers here. Okay, so let's come to the database design. That's the unit 2. So a database design is a collection of processes that facilitate the designing, development, implementation, and then maintenance of an enterprise data management system. So when we talk about the database design is a collection of things that we have to do to either maintain the database or either maintain the database. So these are the things that we have to follow when designing a database. So the first part is the designing of the database. and then the development, implementation, maintenance of an enterprise. So the design, the database design mainly involves the design of the database schema. That's the logical and then physical design of the database. So we are saying that the database design mainly involves the design of the database schema, which is the logical and then the physical design of the database. So the design of a complete database application environment that meets the needs of an enterprise model to a broader set of issues. So properly design a database are easy to maintain. So when you design your database well, it's one, you can easily maintain it. You can improve the data consistency and then cost effective. So if your database is not well designed, you see, it will be difficult for you to maintain it and even to improve data consistency. And then you see that you have to employ a lot of people to design it well for you, so that that's where the cost effective also comes in. So our next focus will be the process to follow in designing database. So we have to follow a certain steps to to design our database. So sorry. So the database design is classified into 4 main steps. The first one is the requirement gathering and then analysis, the conceptual database design, the logical database design, and then the physical database design. So if you look at this, after we have all these things, we put them all together and then it forms the data modeling. But what goes inside the data modeling are the requirement analysis, the conceptual database design, which is the ER diagram, and then the logical database design, which is the normalized database, and then the physical database. So the requirement gathering and then analysis. So we are taking the first part and then we explain what it entails. So requirement gathering and then analysis. In this step, the database designer interviews the domain experts and users to understand the purpose of the system. So for instance, if you want to develop, let's say, a database for a school, or some school have contacted you for a database, yes, that design a database for them. You don't just wake up and then you just go, just start designing for them. You have to at least interview them to know what they want, and then the purpose of the system. What are you going to use the system for? And then also to obtain a document, and also to obtain and then document the data and the functional requirements. The functional requirements, what will this database use for, or what are the functions that you can use this database for? And then establish what requirements involve consultation with, and then agree among stakeholders about what they want from the system, and then express as statement of requirements. So So established requirements involve consultation with and agreement among stakeholders about what they want from the system. So it's expressed as what? Statement of requirement. So what do you want from the system? So that what are the requirements of that what particular thing that you want to what develop? So the result of this step is what? Document. So after we do all these things, then we document what? We document each of the steps. So the result of this step is a document that includes the detailed requirements of provided by the users. So we have what? So you're saying that requirement analysis. So we have to add the analysis to it. So now we know the requirements. What do we need, or what are the functions of the system, or what are the things we need from the system? So the analysis. So the analysis is done by considering the statement of requirement and producing a system specification and then conceptual model. So the aim of the analysis is to obtain a detailed description of the data that will suit the user requirements. Also, both high and low properties of and their use are dealt with. Okay, so I believe with the requirement analysis, it is clear. Hello.
Hello. Yes, sir.
Yeah, I hope the requirement analysis is clear.
Clear. Yes, please, it's clear.
Okay, so let's move on to the
Okay, so let's move on to the next.
Someone is giving me feedback.
Someone is giving me feedback.
Hello. Okay, I think it is okay now. So the logical database design. So in the logical stage, the designer maps the high conceptual schema into the implementation data model of the system that will be used. So the logical model concentrates on the data requirements and the data to be stored independently of the physical consideration. So here we are talking about how the data will be what stored, and what are the data do we need for this kind of what step. So it does not concern itself with how the data will be stored or where it will be stored physically. Thus, this stage is concerned with developing the data model based on the requirement the user what provided.
Sir,
Yes, madam.
sir, please, did you explain the second step, the conceptual one?
Which one?
The second step, the conceptual. You
This
jump
one.
from the first one, yes.
Oh, but I think it is clear, so I don't need to. Okay, so
Okay.
yeah. So they are saying the conceptual data or this schema model. So when it is a formal representation of what the database should contain and the constraints, the rules that the database should have, the data must satisfy. So this stage involves on what and how. It asks questions about what and how. So the attribute to be captured in the database and how to group these attributes to form the various what tables. Please, I hope it is clear now.
Yes, please.
Okay, so let's move on to oh yeah. So I didn't explain. Okay. Thank you for that. It's because of how they did it. I thought it was part of okay, so thank you. So let's move on to the physical. So the physical, after the logical design has been created, now because we saw that with the logical, this stage concerned with developing the database models based on the requirement the user provided. Okay, so after we are done with the logical design, we need our database to be what? Created according to the definitions that we've provided from the requirement analysis, conceptual, and then the logical. So here, all that we need to know is, we need to do is just to create the database based on the things that we've already provided. So the database designer uses the resulting system specification, the resulting system specified database schema from the logical phase to at this stage. So the physical features such as the file organization, the storage structure of the database are specified in the physical design phase. So here we are talking about how we can organize files within our database and how the structure should look like. The result is so the result is the database itself. So with the tables and then the constraints are defined, but will contain no data for the user process. So after we've designed the database, it doesn't have anything for the person to use it. Okay. So we have to stop at 9 o'clock, right? Hello.
Yes.
What time are we coming back?
After 10 minutes.
15 minutes.
Oh, why are you saying 15? The thing is saying 10, you are saying 15. Okay, so let's come back 9:15.
It's now
Yo.
8:37.
8:37.
Yes, it's not even 9.
Oh, my time here is wrong. Oh, thank you.
Okay.
Let's continue. Sorry. My time here is wrong. I'm always 30 minutes late with my time. Sorry. Hey, Elias. Okay, so let's talk about the data storage and then the querying or the query. Okay, so the storage manager, also known as the database control system. The component is responsible for managing how the data is stored on the disk. If we are talking about disk, this can be your hard drive and then the other disk that you know. So if we are saying the database manager, the storage manager. The storage manager is also known as the database control system, the component which is responsible for managing how the database is stored on the disk. So with this manager, it's a component which is also known as the database control system. So it manages how the data is stored on the disk and the movement of the data between the disk and the main memory. So in your operating system, you saw that the disk and then the main memory, they all go hand in hand. So it provides an interface between the low level data stored, the low-level data stored in the database, and then the queries. So you don't know the queries yet, but this particular thing, this particular things ensures that whenever you say, I have a database student, whenever I say, I want, let's say, Kofi, then this particular things, storage manager is the one responsible for providing interface between the low level and then the queries. So the query is like, give me this particular thing. I want this thing, so give it to me. So it's kind of an interface between what I am requesting. So what I am requesting, and then this storage manager will provide whatever I am requesting for me. Okay, so the storage manager ensures the integrity and then consistency of the database by applying the constraint. That is the rule. So here it ensures that the database has some kind of what? Integrity and then consistency. Consistency. When you say consistency, what does that mean? Consistency. Anyone to help? You can talk.
Hello, sir.
Yes, sir, you can talk.
Consistency can also refer to regular.
Regular. Can we use reliability?
Yes, I can use that one also.
And then we can use accuracy as well.
Sure.
Okay, so that is consistency. And then integrity. Integrity is like, if I want my database contains 5, I mean, so the integrity is kind of the quality of that thing. So if I am requesting for a data, this particular thing should ensure that whatever I am requesting has kind of what quality or some sort of what integrity. So it is highly flexible and then scalable product that provides us with the capability of fully managed storage. So the database, so the storage manager is responsible for storing, retrieving, and then updating in the database. So these are the 3 things, or there can be more than that this storage manager they do. So one is what? For storing, another is to retrieve, and then is to update. So some components of the data, storage manager include authorization and the integrity manager, the file manager, the transaction manager, and then the buffer manager. So let's take them one by one and then we'll discuss them and then we'll move on. Okay, so authorization and then integrity manager. So this component ensures that, or ensures the satisfaction of integrity constraint, and then check the authority of the user to access the data in the database. So all that we are saying that if someone is requesting for what? A data in the database, this particular component ensures that whoever is requesting the data is the rightful user. And then whatever we are giving to the person should be what? Should be what? Quality. That's the integrity here. And then it checks, is that person the rightful user or the rightful person to request for this particular what? Data in the database. Okay. And then the file manager. So this manage the allocation of space and then the storage. So this and the data structure used to represent the information on the storage. So this is to what? Allocate and then do allocate spaces for the database. Sorry. This manage the allocation of space and then storage, disk storage and then the data structure used to represent the information on the what? And then the storage. It's like the OS, one function of an OS is to what? Allocate and then deallocate storage when process is what's done. So that's the work for this component that we are talking about, which is the file manager. So this manage the allocation of space, disk storage, and then the data structure used to what? Represent what? Information on the disk. And then we have what? The transaction manager. So the transaction manager, this component ensures that even after the system failure, the database remain in consistent state and concurrent transaction execution process without any conflict. So you can, let me cite an example. So someone can what? Withdraw money. Withdraw money. And then whatever money the person withdraw is more than what the person is having in his account. You see, it ensures that when the system fails, the database should remain what? Accurate and then consistent. So once we have what? So the example I cited, with this, your transaction will fail. If the transaction fails, so the database should be what? Consistent. It shouldn't behave like once my transaction failed, the database should what? No. It should still maintain its what? Consistency. And then concurrent transaction execute process without what? Conflict. So I can, if the first one failed, I can do again, do again, do again, do again. It doesn't mean that once it fails, that's all. No. This particular transaction manager makes sure that whenever the database fails, still it should be what? Accurate and then consistent. And then the buffer managers. So the buffer managers, this component fetch data from the disk and then load it into the main memory. So with the buffer manager, it's fetch the data from the disk and then load it to the main memory. It enables the database to handle large data sizes that are larger than the main memory. So this buffer is kind of what? It's able to what? It enables the database to handle the large data, which is even more than the main memory that you are having. So we have some of the data structures implemented on the on the storage manager, So there are some of the data structures. So when you talk about data structures, it is how your data is being organized, stored, and then how you can manipulate this kind of data, the data. So some of the data structures implemented on the storage manager includes data files. So this stores the data in the database, and then the data dictionary. This stores a metadata about structure of the database, and then the database schema. And then we have indices. This can provide fast access to a data item. So it's something like a data index provide a pointer to a data item that hold a particular value. So the index are just like a pointer, or let me say you have you've stored a data somewhere. So this thing, the indices point to a particular location that you've stored that data. So if we use an index to find the product record with a particular ID, we find that product. So for instance, if we have a database somewhere and then we have ID, so the indices just point to that particular location that we've stored that particular data over there. So if I say give me a particular product ID, maybe 500, then it will give me that particular thing. So mind you, I said the database, the data structures are how we've organize, how we've organize, we store, and then we manipulate our data. Okay. So let's move on to the query processor. So the query processor is also another important component that help the database system to identify and then facilitate access to the data. How we can facilitate, or we can access data in the database. So it translates queries written into a non-procedural language at a logical view. So the last time we said, how many views do you have? How many levels of the last time, the first, we saw the logical, and then what again?
Physical.
And then what again? Oh, it's left with one. The one at the
the view.
The view. So which one is at the middle?
The logical.
The logical is in the middle.
The logical is in the middle.
Yes, sir.
And then the view is what we see.
The highest one at the last one.
That's the lowest, or not that?
The lowest.
The lowest. Oh.
Is the lowest?
Yes.
Okay. So so it translates queries written into a non-procedural language at the logical level into an efficient sequence of operations at the physical level. So the query processor component includes the DDL, and then DML, and then QEE. So let's take them one by one, and then we look, we try to understand what each of them do. So when we take the DDL, so the DDL interprets. So it interprets the DDL statement and then records the definition in the data dictionary. So that's it's used to build and then modify the structure of the table. It is used to build and modify the structure of the tables and then other objects in the database. So the DDL, so that's the data definition what language, or not that. So with this one, it is a set of commands. Let me bring in another thing apart from what we have here. So it's a set of commands used to define and then manage the structure of the database. So if you look at this, it is used to build and then modify the structure of the database or the structure of the table and then other objects in the database. Please, I hope it is clear. So the DDL is used to build and then modify the structure of the database. So that's the DDL. So the data definition language. And with this one, it is used to modify and it is used to build and modify the structure of the database. In other hand, it is also used to define and then manage the structure of the database. Okay, so let's come to the DML. So the data manipulation language. So this handles the insert, deleting, and then modify data in the database. So with this component, with this component, it is used to handle insert, deleting, modify data in what? In the database. So it translates statement into a query language. It translates statement in a query language into an evaluation plan consists of low instruction that the query evaluation language understand. So with this data manipulation language is how we can what? Manipulate data in the database. So we should take it like that. It is how we can what? Manipulate data in the database. And what kind of manipulation are we talking about? One is how we can what? Insert data into the database. And then two, how we can delete maybe a column or a row or something in the database. And then how we can also what? Modify data in the database. So the DML compiler also perform query optimization. That is, it selects the lowest evaluation plan from among the alternative. So all that we are saying at the DML is how we can what? Make modification or how we can manipulate data in the database. And then these are the things that we do when it comes to what? The DML. And then the another thing is what? The query evaluation engine. So it basically executes the low-level language instruction generated by the DML. That's the compiler, the DML compiler. So whatever we do, the query we do at this site, at the DML, this basically what executes it to a low level language instruction. And then we know the low level language the computer understands is the zeros and the ones. And then this is being performed by what? The query evaluation language. Okay, so I think we will end here and then we'll come back, then continue from the transaction management. Okay, so when it is 9:10, then we'll come back. Thank you. Hello, are you with me?
Yes, sir, we are here.
So
We are here.
when it is 9:10, then we come back.
Okay, sir.
Yeah. Oh, no, thanks.
Yes, hello. Good morning to all of us. Please, I have a little submission. It's about the e-learning group work. Um, please, let's try and check up on each other. Those on in my group, I don't have their contacts. So let's, for the names that are on the, what's the name? Your contact names, it doesn't really tally with the names I have on the group. So please, let's look for each other. Okay. Thank you.
So in this case, since the groups given on the platform has no contacts, how do we contact our colleagues? Because the telephone numbers are not part. So in this case, how do we do the contact? Class rep, if you can help in this
I am
regard.
of the view that let's all create our various WhatsApp group for the various groupings that the man has done. So let's say group one, you create a WhatsApp group, put the link on the page. Group two, in that order, so that we can all join the various WhatsApp groups. That's my submission. That's my view. Or let me see, Baba. I don't know. I don't know if I'm being heard.
Yeah. You are heard loud and clear.
Okay.
Or can you also create one like the community based group you have been doing so that we just share it into the group and then we'll all join? Because maybe this one, two or more people from the same group will create duplicates of their group and that will also be an issue.
Okay, I'll look at it. I'll look at that too and see. Thank you, sir.
Hello. Can we continue?
Hello, sir. Please, I think most of us haven't joined. You are still 22 now, so I plead you give us about 3 minutes more to join. Thank you, sir.
Okay. Please, we should tell the others to join because we are far behind time.
Yes, sir. Please, I've put it on the page that they should join. So I think they are joining. You are now 30, sir.
Okay, I think we can start now. Okay, so with this session, we are going to talk about transactions management. So we can just even find the whole thing from this side. So most often, several operations on the database form a single logical unit of work. For example, the transfer of funds from account A to account B. So it is critical for both debit and credit operation must either occur successful. So for instance, with a transaction, if I am to transfer a fund from account A to account B, meaning that whatever I do, one should be credited and then one should be debited. I shouldn't have a situation where one is debited and then one is not credited. They should all have what? Equal operation. That one should be credited and the one should be what? Debited. Operation. Should be occurred successful. The word here is successful, or neither should occur. Either both of them occur or both doesn't occur. That's the transaction. So if an error occurs whilst performing the operation, the database must revert. So revert means that roll back. So for instance, if you transfer money from your bank account to your Momo, sometimes you could realize that they've debited you in your bank account, but then they've not credited you in your Momo account. If it happens such, the bank people should revert it back, which we term as rollback or modification done. So the money they sent and it didn't go, it should come back to their bank account again. That's what we term as the rollback modification. So to the state before the start of the operation. So that's what I explained. So by the end, we should understand what a transaction is, and then transaction has some properties, which is the asset, the atomicity, consistency, and then the rest. We'll look at them one by one, and then state order and explain the trade transactions that we have. Okay, so when we say transaction can therefore be defined as a collection of operations that can be performed or performs a single logical function in the database. So the transaction is a collection of operations, and then we'll look at the operations later. A collection of operations that perform a single logical function in a database. So each transaction is a unit of both atomicity and the consistency. So they are saying that each transaction is a unit of both atomicity and consistency. So thus, we require that transactions do not violate any database consistency constraints. So when we look at consistency, you would understand what this line means. So it does not, we require that transactions do not violate any database consistency constraint. So does not violate any database consistency rule. So we require that the transaction do not violate. So if one is credited and one is not debited, meaning that we are violating this kind of rule. If one is debited and the one is not credited, meaning that we are violating this kind of rule. So you see that we have an example here. So before the account A is what? It's having what? $30. And then before account B is having what? $100. So you see that here account A, we transfer what? $100 to account B. So you see that the available balance for account A is what? 20. And then available balance for account B is what? 110. This is what we are talking about. You see that debited successfully and then credited successfully. We shouldn't have a situation where this particular thing is debited and then this is not what? Credited. It means that we are what? Violating this what? Transaction what? Constraint, consistency constraint here. We are violating that. Okay, so when we talk about transactions, we have some kind of properties that we have to follow. So just as I said, we have what? The atomicity, consistency, isolation, and then durability. So these are the things. These are the abbreviations that form what? The acid property. So the acid property are used to maintain the integrity of the database during what? Transaction process. So we use these kind of properties to what? To maintain the integrity, to maintain the accuracy of the database, the accuracy of the database during what? This transaction process. And then the acid stand for what? Atomicity, consistency, isolation, and then durability. So let's take the atomicity. The atomicity is a single what? Unit of operation. That is atom. Atom is just a single unit of operation. So either you execute it entirely or do not execute it at all. So all or none requirements. Therefore, it cannot be what? Partial. I hope you understand. So when we talk about atomicity, it's either we do or we do not. We don't have anything like partial here. That, oh, let's do something half and then no. So if this place is debited, this place should also be what? Credited. We don't have a situation where this place should be what? Debited and then this place is not what? Credited. We don't have any partial in what? Atomicity. It's either you do or do not do at all. That's what? Atomicity. And then the consistency. Once the transaction is executed, it should move the database from one consistency to another. So if this is what? We are to debit this side 10, meaning that the available balance should not be what? More than what? 30. It should be lesser than 30. That is what? The consistency. Once the transaction is executed, it should move the database from one consistency to what? To another. So when the database is what? Debited, it should what? Move it to what? 20. Okay, to another stage. So the isolation. So the isolation has to do with the transaction should be executed in what? Isolation from one transaction. No deadlocks. I hope you understand. No deadlocks. You understand deadlocks? Hey, no locks. Or it kind of what? Deadlock. So the transaction should be executed in isolation from one another. So once we are what? Making payment at the same time, we should not be doing what? Receiving payment. So the transaction should be executed in isolation from one another. During the concurrent transaction execution. Immediate transaction result from simultaneously executed transaction should not be made available to each other. So if we are what? Sending money. I'm using sending money. If you are sending money, the buying of credit shouldn't be what? Available to us. That's what this is saying. That one should be what? When we are what? The transaction should be executed in isolation from each other. So we shouldn't be doing what? Two transactions at the same time. Two things at the same time. If we are buying credit, the option of what? The option of transacting money shouldn't be what? Made available to us. That's the isolation. And then the durability. Once a transaction completes successful, the changes it has made to the database should be what? Permanent. Even if the system fails. So if the transaction is successful, whatever money that you have, if it's money that you are sending it to somebody, it should what? The changes should what? Reflect. Even if the Momo people or the MTN, the database go off, it should what? Reflect. If there is a failure or something, the recovery management component of the database system ensures the durability of the transaction. So the recovery management ensures the atomicity and then the durability of the transaction. Thus, it ensures that the database is always in a state that is recoverable consistently and then correctly. So this is done by ensure that the database contain all or none of effects of committed transaction and none from aborted or what? Running the transaction. So let's see some transaction state here. So we have a transaction state in a database can be in the form of the following state as shown in figure what? 2.6. So we have, I think this is in OS. I don't know if you've seen it in OS. So we have an active state. So the active state, we can what? Perform read and then write operation. So this is partially what? Committed state. And then we move on to what? Committed state. That's the permanent. So here what? We try to terminate the state. And then if it fails, the failed state, we what? We roll back. That's where we get the abort. And then the process also terminated again. If it is partial, it can fail. If it is fails, it means that it moves from this direction to what? The terminated state or the terminate state. Okay. So let's discuss each of the what? The state one by one. If a transaction is in execution, then it is said to be in an what? Active state. So once we start to perform the transaction, it means that we are in this state, we are in the active state. So it does not matter which step in the execution. As long as the transaction is executing, it will remain in an active state. So let's move on to the failed state. Once we are in the what? The active state, we can what? failed, it doesn't mean we can always what? Move to the next state. We can either what? Fail. So if a transaction is executed, which is active, and then fails occur, or failure occurs, either a software or hardware failure, then the transaction is said to be what? Failed. It can be a hardware problem, it can be a software problem, but then we call or we term all of this to what? We say that our what? Our transaction is what? Has failed. Okay, so the partial what? Committed states. Again, as you seen in what? 2.6, a transaction is said to be in a partial committed state when there are read and write operations. So if a transaction is in what? A partially committed state, so it means that in this kind of state we can read and then we can write. There are read and write operations presented in the transaction. In a partial committed state, the transaction has been what? Successfully what? Executed, and read and write operations are performed on the main memory instead of the actual what? Database. Can you think of the reason why this is the case? Can anybody think of that? Why is it that we are dealing with the main memory but not the actual database? Can anyone help us? Oh, class, can you help us? Or we can move on. Okay. So someone is saying for recovering purpose. Yes. Yeah. Because if we are to deal with the actual database, meaning that if our system fails, then there should be an issue, because we are not going to recover whatever we were using. Because with the main memory, we saw that when the machine goes off, it stores something temporal. When the machine goes off, it reflects back to the actual state. That's why we are dealing with the main memory. Yes, your answer is correct. And then the committed state, if a transaction is executed successful, then all the changes made in the main memory during the partial committed state are permanently stored in the database. So the person who gave us the recovering purpose, you are right. So the committed state also what mentioned what you just sent to us. So thank you for that. So in figure 2.6, you can see that the transaction goes to the partial committed state, which is the kind of dealing with the main memory. And then if the transaction is committed, then we terminate. So partially committed, then to committed state, if transaction is successful, then we what? We terminate. So the abort state is when the transaction fails during what? Execution. Abort. If the transaction, the active transaction fails, we can abort it. If it is fails, we abort and then we terminate. That's with what? End the transaction. So when a transaction fails during execution, then the transaction goes to the failed state. But then you can see that the transaction can also be in what? Partial committed state, but it can still what? Fail. Okay. So then the changes made in the main memory or the buffer are rolled back to the previous consistent state. So the transaction then goes into the abort state from the failed state as shown in the diagram. The interaction between the failed and then the abort. Okay. So that is session 4 for you. So the session 4, we just talk about how we can do transaction in the database, and then the transaction has some kind of property, which is the ACID properties. The A stand for the atomicity, the C stand for consistency, I stand for isolation, and the D stand for durability. Okay, so these are just the kinds of properties that we can do during transaction, and some transaction states that we have. Okay, so the database architecture. This one we are just looking at how the database is organized, or how the database look like. So the design of the database depends on its architecture, the layout. It can be either centralized or decentralized or hierarchical. So the database, the architecture of the database can also be seen as either single tier or multi-tier. Okay, so we'll look at all these things. So an n-tier architecture device. So n means that the kinds of the 3 types of the type that we have. That's why we are representing with an n. So the n-tier architecture divides the whole system into related but dependent on n modules, which can be divided, which can be independently modified, altered, changed, and then replaced. So there are mainly 3 types of DBMS architecture: database management system architecture. So we have the first tier, we have the second tier, and then we have the third tier. And then with the first tier, we are saying it is a single tier architecture. So with the single tier architecture, the database management system is the simplest architecture of. Let me read it again. The single tier architecture database management is the simplest architecture of the database, in which the client, server, and then the database all reside on the same machine. I hope this is clear. With a single tier architecture, we mean that the client, that is you the person, and then the server, and if we say server is where we store our base information on the database, and the database itself all reside on the same machine. That's the single tier. So the database is directly available to the user. That is, the user connects directly to the database system to run queries. That's the single tier. Here we are saying that the server, the client, and then the database, they are all in the same PC or in the same machine. So in this structure, any modification done by the user, which is the client, are reflected directly in the database, and all the processes or the processing is done on a single server. Also, no network connection is required to perform action on this kind of database. And first tier or a single tier database architecture is often used by database designers also for development of an application locally. So with this kind of tier, we the database designers we use it the most, mostly for development purpose, where the programmer can directly communicated with the database for faster response. So an example is when you install a database in your system. So maybe you use my PHP admin with my SQL. With this, when we get to the database too, that's where we'll see all this kind of tier this thing. So let's try to understand the concept. When we get to database management too, we'll understand it better. So the following are some of the situations where a single tier architecture is preferable. So here, the data isn't changed frequently. So maybe you are creating the database, you don't change some of the tables often. That's where you have to use a single tier. And then only a few users, so only one person. That's where you can use a single tier. So we'll be using the database. There is no need for a direct and a simple way to modify data. So these are the preferable way when it comes to using of the single tier. Now let's shift our attention to the second tier. So with the second tier architecture, it's similar to the fundamental concept of the client server, which is the first tier architecture. So in this structure, the server provides please, you are using media. Is that your name?
Yeah, my name is Adimpo Victor.
Adimpo
Victor.
Okay. Are you the course rep?
No, please.
Okay, please, then you continue.
Yes. I have a question.
Okay.
With the first one, the one tier architecture. It says only few users, usually one person. Can there be multiple users with different accounts on the same database?
No. That's not what we are saying.
No, I'm
the
just
single tier. The single tier. I'm coming. The single tier is saying that it is a simple database architecture in which the client, the server, and then the database all referred or all reside on the same machine. So if it is one machine, how can a multiple users uses that machine? Please, I hope it is clear.
Yes, please.
Yes. So we have a situation where it is preferable. So it is preferable when the data isn't changed frequently, or when only few users, usually one person. That's where the first tier architecture comes in. Okay, so let's move on to the double tier or the two-tier architecture. So it's a fundamental concept of a client-server architecture. So in this structure, the server
Yeah.
provides.
Yes, sir.
Yes, boss.
Please, there's the single tier. We said usually few users. Well, and we have also said that one user. So does that mean it can be more than one? Few users means maybe two users. If it is one, then why don't we make it an exact, a maximum of one? Because if you say few users, okay, two are also few users, three are also few users. So let's get a clarification clear over here. Thank you.
So if you see what is in the bracket, it's saying that usually what one person, few users, maybe I don't want to complicate things, but let's take it like this particular thing is what is solely for only one person. Let's finish this all the architecture, then I'll come back to the few users that they are talking about.
Okay.
Okay, Bismarck, Mr. Bismarck.
Yes, so it means that the client, the server, and then the software are on
Database.
one computer.
Yes.
Or sorry, on one database. So
no. On
one person
computer.
can come
Yes.
to that. So which means that one person can come to that device and then use it, and then another person comes later on. Is that so?
Yeah, something like that. Something like that.
Okay. So which means that one person can use that device at a time.
Yeah, at a time. Yeah.
Thank you.
Media, you can continue.
Yeah, that's why I was seeking for clarification. The client, the server, and the database are the same on the same computer. But here, can there be multiple accounts? Maybe main admin accounts.
No. Yes. You can have a multiple account for that machine, that particular machine.
But purposely for that machine.
Yes.
Good. Thank you very much.
Or you can have one machine sitting somewhere that contains all these things. Then maybe we have some other mini machines that they can connect to. That's why I said I don't want to complicate things here. So let's finish the tiers, then we'll come back to these things again. But I think the reference the guy Mr. Bismarck made was quite clear for us to understand. Mr. Bismarck, do you want to talk again? Your hand is up.
Yes, sir, please. So it means that we can have maybe a local area network where people from different devices can access that machine alone.
No. If we do that, meaning that we are shifting the attention towards the second tier. So let's find whatever is in second tier, and then we try to relate it to the first one and see how the both of the concepts we relate two of them and see how they are. So the second tier database. Second tier database system architecture is, they are saying, is what a fundamental concept of client server architecture. So in this structure, the server provides all the database functionality and allow client to perform operations on the database application through the client and usually using APIs. usually using API, and then APIs are application program interface. So with this, we have client server somewhere. We have client and then a server. So in this structure, the server provides all the database functionality, and it allows the client to perform operation using this API. So meaning that with this, we have server somewhere, and then the client access information to this server based on using this API, such as open database connectivity, and then Java database connectivity. So this client access this information using these APIs, and such APIs are what I have described here: the open database connectivity and then the Java database connectivity. So the two-tier architecture is often used when a database must be accessed with the help of an application. So an example of the architecture can be seen in figure 2.7. So you see that the database is here. The database is somewhere. And then there is an application the user access through this application to reach this database, which is the server. So the client and then the server. Okay, so let's move on. So the main advantage, so the main advantage of having a two-tier architecture over a single tier include multiple users. So with this one, the advantage over the single tier is what? Multiple users. So clearly, this is telling us that the single tier is for only what? One person. Or one person can use it at a time. Maybe we have 4 database administrators. If it is in a single tier, one person can access or use that machine at a time. That's what this thing is telling us, that multiple users can access the database at the same time, usually in an organization. And it provides high processing ability as the database functionality processing ability as the database functionality is handled by the server alone. And then it faster access to the database due to the direct connection and then improved performance. And it's easy to maintain since it has 2 independent layers as compared to the first one. The first one, it has 3 of them: the server, the database, and then the client. So let's move on to the third tier. So this is the most popular client-server architecture in DBMS, in which the development and then the maintenance of the functionality, the maintenance of the functional process, the logical, data access, the data storage, and then the other interface are handled independently as a separate modules. And then this architecture is an extension of the second tier client server with additional layers. So the additional layers that we are talking about are the logical, the data access, and then the storage, and then the user interface handled by a separate user modules. So this extension, this architecture It's an extension of the with additional layers. So that's what the presentation layer, the application layer, and then the database server. So with the presentation layer, it talks about the computer, the user computer, the user's computer, the smartphone, and then the tablet. That's the application layer. Okay, that's the presentation layer. But with the application layer, is what? The application server, and then the database server. So with this one, they've added what? Some extensions to this the third tier. And then these are the extensions that we are talking about. 3 of them. And then all the users requires are handled by the application layer. So if a user was required or user is at the presentation layer and it needs something, it's the application layer that the user goes to first. And then before being transferred into the database server, there is no direct connection between the client and then the database server as compared to the first one, the second tier. The second tier is what? The client and then the server. It means that the client has what? Direct access to the database server. But with this one, no, that's not how it is what the architecture looks like. The architecture for the third tier is the presentation layer does not have any direct access to what or direct link to what the database server. It is in this way. When the user is trying to get information, it hits what? The application layer. Then the application layer goes to what? The database server to fetch the information to whoever needs it. So there is no what? Direct communication between the client and then the database server. So an example of the third tier can be seen here. So here you see that at this side, there is no what? Application layer at this side. So if a user needs what? Something, it goes direct to what? The application layer. But with this one, if a user needs something, it will come to the application layer, and then the application layer will go to the database in that manner so that the user will get the information. Please, I hope the architecture is clear. The database architecture.
Please, can you explain that again for one more time?
Which one? Or
No,
you mean all?
The diagram. No. Just the last.
Okay. So all that we are saying with the second tier, if you look carefully for the second tier side, if you look careful, here we have the application here. The application the user is trying to use to access the database. And so here you see that it goes direct to the database. That's the second tier. So the second tier, the user has a direct link to the database or direct access to the database. But with the third tier, you see that it is having the user, the application, and then the database itself, just as we saw here. So the presentation layer, the application layer, and then the database server. And then we said the presentation layer are the are the users, the machine or the thing, the desktop the user is using to access particular database. And with this one, there's something in between the user and then the database. So here the user does not have direct access to the database. If the user wants something from the user base, it comes to the database, it comes to the application server, and then this server will also has what? Direct access to what? The database. So with the third tier, users are not what? In direct contact with the database. The users contact is to what? The application server, and then the application server will make contact to what? The what? The database server. I hope it is clear.
Yes, sir.
Okay, okay. So the database users and then the database administrators. This one we don't have to even talk about, but we have to. So a database system can be accessed by a different type of users. Administrator is a user. So each have a distinct needs and then access levels. So all that we are talking about are these particular sides. Let me take for instance, let's use your student portal, for instance. You see that with your student portal, if you go there, you can only view your resource. You can't change your resource over there. I hope you understand what I'm saying. You can only view your resource, but you can't change the resource over there. That's the access level that we are talking about. But let's take, for instance, maybe a lecturer. A lecturer can maybe change your resource or something. Or let's say a database administrator can change your resource. That is the kind of access level that we are talking about. So each differences are often determined by a real world constraint, such as a person's position in an organization. Exactly. So a CEO, the functionality for a CEO is what? Different from what? Functionality for normal what? Just
Garna kaprumulumu, kamna.
Abubakar Mubarak.
Sorry.
Oh, you didn't give us meat and then you are disturbing us. Abubakar.
Sorry, sir. I'm sorry, sir.
Okay, that's just by the way. Okay, so someone's position in an organization. So the knowledge about the internal computers and then the security clearance level. So in this session, we'll discuss all this. You will know how database determines what user can see or do on access or something. So the database user and then the interface. So a database users are categorized based on their interaction with the database. So there are 4 types of database users. They are differentiated by the way they expect to interact with the system. Different type of user interface have been designed based on the type of users. So one is the application programmers. And then the second is what? The sophisticated users. And then the third one is a specialized user, and then the naive users. So let's take them one by one, and then we'll know how these users are. So the application programmers. So these are developers who interact with the database by the means of queries. So with the application programmers, as the name even suggests, or the name says, application. So they are what? The developers who interact with the database by the means of what? Using queries. So the queries are just written in programming language such as what? Java, PHP, Python, to communicate with the database user interface. So the application programmers also use a rapid application development tool, which enables them to generate form and the reports with minimal programming effort. So all that we are saying that the application programmers are just the developers who day in and day out interact with the database by the means of the queries. And then the queries are just the written in programming language, just as we normally do. And then the sophisticated users. So they can be an engineers, the scientists, and then business analysts who are familiar with the database and then submit queries to explore data in the database. They can develop their own database application according to their requirements. They don't need the programming code. For them, they don't need the programming code, but they interact with the database by writing an SQL queries. So with this particular one, they don't write programming language anything. All they do is they write SQL queries. So SQL queries directly through the SQL processor or by using tools like data analysis software. So data analysis software like R and then the rest, they use it to do all these things. That's why they are saying sophisticated users. And then we have the specialized users. So the specialized users, these are also sophisticated users who write special database application program that are quite different from the traditional data processing framework. So these people uses some of the application are the expert system, the knowledge base system, and then the computer aid system that are stored with a complex data types. For example, graphical data types and then audio data types. So with these specialized people, they are also like the sophisticated users. But with them, they write special database programs or database applications program that are quite different from the traditional framework. Just as we saw with these people. These people, they write SQL query. So, and then most of the things that they use computer aid program, aided design system that stores data which are complex. So, for instance, graphics and then audios is very complex to store all these things. If you want to store something like picture, you have to do a lot of manipulations and then as well as the audios. And then the naive users. So the naive users are unsophisticated users who interact with the system by using programs that are being written by application programmers. So with these people, the naive people, they use programs that are written by the application programmers. So thus they use the existing application to interact with the database. So for instance, for example, you interact with the UCC database by the student portal. So the student portal was developed by these people, the application programmers, and then through the program they develop, you are using it to interact with the UCC database via the UCC database via the portal library management. So that is that. So these are the kinds of database users that we have. There are 4. 1, 2, 3, and then 4. And then the database administrators. So the database administrators, this administration, and then so they deal with the administration and then the maintenance of the database are taken care by these people. So they make sure that the administration and then the maintenance of the database are taken care, or these are the people who take care of the database, the administration level and then the maintenance level. So this administration and the maintenance of the database are taken care by the database administrators. So that's the DBA. So the DBA are the administrators of the database. So the database administrators, either a person or a team, has a central control over the database system. So they can be a team, or it can be just one person. So has a central control over the database system. So the functions of the DBA include the schema definition. So the database administrator creates the original database schema by executing a set of definition statements in the database, a data definition language, that's the DDL. And then routine maintenance, so such as ensures that there is enough free disk space is available for formal operation, and then periodic backups. So the routine maintenance is one, ensure that there is enough disk. That's one work of the DBBA, the DBA. And then periodic backups. So the DBA makes sure that you back your data every day, and then it's monitorings, or they monitor jobs and the query running on the database and ensure that the performance is not degraded by an expensive tax submitted by some of the users. And then another thing is the database administrator also provides technical support for users who face challenge. So maybe we have a student who cannot log into his portal. Maybe when you call the administrators, they will try and then resolve the issue for you. If there's a need to change the password, they will change it for you. And then they also define the storage structure. We saw it here. We saw it at the routine maintenance level. So they define the storage structure used by the database system, and then the access method defined by them. So how is our database structure? How does it look like? How do we store data in this? These are the work of the DBA. And then another thing is authorization of data access. So with the database administrator, he can authorize who can change or modify data, who can view data, and then the rest. So the database administrator is responsible for granting different type of what? Authorization to users. Mind you, the database administrator is also a user. So doing so restricts the operation of a various user can perform on the database. So the example I cited with your portal, you can only view your results and then you can maybe change. Even your name you can't change. Maybe there are certain things you can change. Certain things which does not effectively change the state of the person or maybe a uniqueness of that person. So doing so restricts a various user can perform on the database. The authorization information is saved on a specific on a special structure, system structure that the database uses to allow or disallow access to the data in the database system. So with this, it makes sure that an authorized person can access the right information. So if, for instance, your student portal, you can change your results, what do you think will happen? What do you think will happen?
I'll change all my results to A.
Yes, you will change all your results to A. So in this case, we don't want to happen it that way. That's why we provide access based on the user's authorization. So doing to restrict some operations, some of the things that we cannot perform on the database. So if we give you only read access, meaning that you can access, you can only read whatever is there. You can't change whatever is there. But if we give you read and write, it means that you can read and then as well as change or make modifications to your data. That's not what we want. And then another thing is schema and then physical organization modification. So as a organization needs keep changing, it is responsible for the database administrator to update the schema. Maybe we have a database which we don't have maybe so for instance, let's say we have a database for school. Maybe we've introduced another course. We can, as the needs changes, it is the work of the administrator to keep or update the schemas of the database or of the organization, and then physical organization of the database to accommodate this kind of changes. So we are done for today. So since we have a lot of time, let's try to go through the assessment together. I think we have like about 31 minutes or something. Let's just go through the question one by one and then. So the first question, someone should read for us and then. So someone should read for us the first question.
If a user doesn't know anything
hold on, Mr. A. Mr.
Yes,
A.
sir. Yes, sir.
Okay, so you will be doing the reading for us, and then you will ask the class to give us our response. Is that okay?
Yes, sir.
Okay, so please, let's continue.
If a user does not know anything about the complexity of a database application, then that user is called.
To class, to us, that user is called what?
Naive user.
So
Naive user.
That's the naive user. Okay, Mr. A, let's go.
Monitoring the job
hold on.
running.
Hold on. Please, what's your name?
Andy.
Okay, Andy. I don't want to call you Mr. A again. Mr. Andy, you can continue.
Okay, sir. Monitoring the job running on the database should be supervised by.
Okay, should be supervised by. Please, class, the answer.
Database administrator.
Administrator.
Database administrator.
Database administrator. Okay.
Okay.
So with this one, Mr. Andy, hold on. With this one, you see that it is clear. You can see an option with maybe database administrator, database user administrator. This one, you see that there's kind of what confusion.
Yeah.
Yes, if the options are in that manner, you see that there will be some sort of confusion. But all that we need is what? Once it is database administrator, you have to what? Specify the kind of administrator the person is. Any administrator is an administrator, but
Yes.
what is the person? I hope you get it.
Yes, please.
Yes,
So
please.
in this case, you can modify and say that maybe we have, let's say, super admin, we have general admin. What depend on the work that the person is doing.
The person is doing. Thank you. Thank you. So this one, it is database administrator. Let's go on. Mr. Andy.
Defining storage structure and access method is a job done by.
Class, it's for us.
Is the same admin? Is a database admin?
So defining storage structure and then access method.
Or manager.
Is it the manager?
The manager, the database manager.
This one is not the administrator.
The administrator
is the administrator.
Is the administrator. Say you see, do we actually have manager? Now the administrator's work is that he defines.
Anyone to help? Hello, class. Class, is it the database manager or the database administrator?
So it's administrator.
Why?
So I will choose database administrator.
You will choose, but I want to know why.
Sir.
Yes, sir.
I also go for administrator because the same administrator is who is responsible for managing the database. So I think it's the administrator. That's not.
Hello, sir.
So number 3(2) is D, right? Okay, so let's go on to the number 4. You want to talk, Naomi? Madam.
Yes, I was adding to what our brother just said. That is the database administrator. This is because he is in charge of the system, the structure. And so if he does that, then he manages, and also, so he manages, and with the access method system, he's still in charge. So I think is the administrator.
Hold on, I'm coming. Please give me a minute, I'm coming. So Mr. Andy, you can read.
Okay. Ensuring enough free disk space is available for normal operations is the responsibility of ensuring enough free disk space is available for normal operations is the responsibility of.
Okay, so class, answer. Class, any answer?
Sir, it will be
Sir, is a database
database administrator.
Okay,
Because
because
based on number 3, if even
yes,
number 3, the structure,
he,
the storage
he,
structure.
he ensures that the free
Yes.
broadband. Okay, so Mr. Andy, let's continue.
A farmer goes to an ATM center to withdraw money. Which type of user is the farmer?
Okay, anyone to help us?
Unsophisticated. So it's unsophisticated user. Hello.
I agree with him, sir.
Yeah, that's the A, right?
Yes, A. Yeah.
Okay, so that's the unsophisticated what?
User.
User. But they have another name.
Naive user.
Yes, that's the naive user. Thank you. Mr. Andy, let's move on.
So how about the end user?
End user.
Sir. Yes.
Well, so if you have naive user, end user, maybe specialized user, and then application user, which one will you go for? You choose the odd one out. Which one will
I'll
you
go for naive.
Yes. But in a situation where you have what?
A person
Sophisticated user. I'm coming.
Okay, sir.
In a situation where you have a sophisticated user, application programmer, specialized user, and then end user, which one will you go for?
So I would say the end user.
Yes. So that's how we answer most of these objective questions. So you just choose the odd one out. Okay, so Mr. Andy, let's move on.
Person A is a Java developer who interact with person D to understand the complete database schema, right? Written by him. Person B knows the database schema and is able to make complex queries. Unlike person B, person C does not use a framework. Who among these 4 users will be called a sophisticated user?
I think this one is more a little bit what?
Confusing.
Yeah. Okay, so a person A is a Java developer who interacts with person D. Who understand the complete database schema. So meaning that this person depends on this, right? To understand the database schema, or let me say to understand the database. Is that okay? So this person A depends on what? Person D. But then there's another person also, person B, known as a database schema, and is able to make complex queries like person, unlike, wait, please. Who can make, so person B can make complex what? Queries.
Queries.
So unlike person B, person C does not use
Small
a
use traditional processing framework.
framework. Among the four users, I think one user is missing.
The user is not missing. Now we have all the four.
No, we have user A.
Developer.
Yeah. We have user
So
A. Okay. All of them are here. A,
D,
B,
user
C.
D also
Yeah,
understand.
all of them are here.
They are all there. So I think the answer
Unlike
is C.
person, I'm coming. Unlike person B, person C does not use what? Traditional. Also, the answer is there. So what's the answer?
Yeah, it's C. I think it is person C because he doesn't use the traditional database.
Yes, exactly. Okay, so Ebenezer, this is how far we've gotten to. So please, if there are no questions, but then do you have any question that we should look at, or you don't have any question? Please, any question? Okay, so if there are no questions, we'll end here and then see you next week, God willing. I hope you are
Yes,
coming
sir.
next week.
Yes, sir.
Okay.
Yes, sir, we'll come.
Okay.
Thank you very much, sir.
You're welcome. Thank you too for joining. Okay, so see you again next week. Bye-bye.
Bye-bye.
Bye.
And have a good day.
See you too. Have a good day too.
Yo, group 9 members. I beg, make you join the group, Make we see what we go do.